right. Anybody's logged in from here to the session? Because I see somebody's online. This class is not online. This is for just recording purposes. So you're not allowed to join online. People who are online are going to be, nobody's logged in from here, right? Yeah. Okay. Okay. All right. So, yeah. Let's start the session. I don't know if you know or not, but I'm from an Iranian descent. I haven't been to Iran for like 20, 30 years, but my root and DNA comes from there. And people are getting killed over there by thousands just to be free, because free, like things that we take for granted. We can talk and we can state our opinion here and enjoy our freedom. Over there, they are getting killed by thousands every day just to get out of oppression. So my sympathies to all those who are losing their lives over there, and it's a crazy thing. Just listen to the news and be their voices. They need people to talk about it and help them. They are very, very desperate. Anyways, everything's closed. Nothing comes out. I only have an uncle and a cousin over there, but I haven't heard from them for since this. Nobody really knows what's happening. Be their voices. That's all. Sorry. Pardon me? No, no one can. I ask anybody that I know is from that descent, like, have you heard from them? And everybody said no. So we don't know what's going on. I hope they're safe, and I hope they get what they're looking for. Anyways, so let's start. I am quickly going to go through what we've talked about last time, and then start week 2 and go through everything. If we can finish it today, we'll finish today. If not, it's going to leak to the lab session as usual. We talked about namespaces. We said the purpose of namespaces is to make sure that when you're actually creating a compound type or creating a function of anything that you want to be used in your application, not to have a duplicate name if someone else have another abstraction and wants to design the same thing that does focus on different aspects of it. We said that for in every namespace you can create your own compound type, and the namespace clarifies what the compound type is doing over there, and it specifies which compound type you're dealing with. We said that all the stuff that namespaces, something that were introduced later in C++ language. Because of that fact, initially we did not have anything called STD, but after the namespaces were introduced, all the original entities of C++ was inserted into a namespace called std, and that's why whenever you are using any library, anything that comes with standard C++, you either have to use the namespace std or you have to qualify the name to be able to use it using the namespace and the scope resolution. Then we talked about making a module, and I said that making a module should be something that goes into your muscle memory. You need to understand that every module has a header file and a CPP file. The header file is enclosed in what we call a compilation safeguard, which is made up of the preprocessor directive called if not define, and then define and an end if. The flag of this compilation safeguard is something that you have to build up of two things. One, the namespace in which you're developing that module. Two, the name of the header file. So if the namespace is Seneca, we're going to have Seneca, and if the module is student, it's going to be student header file. So Seneca underline student underline H, and that's the name of the header file. And then we write the namespace. So essentially this becomes an empty namespace that an empty header file ready to be filled in with information you want. Student.cpp is where the definitions of all the declarations implemented in the header file will reside. Obviously, it's going to include student.h to have access to the declarations, and then you're going to again create the namespace Seneca to put everything in it. So anything as a student in Seneca you create in OOP244 class should reside in that. So when you are creating a module, you don't need to ask any question. The very first thing you need to do is to build that module that way. So if I told you create a module for a teacher, immediately you're going to have to create a teacher.h and a teacher.cpp. Then you have to create a compilation safeguard with a flag that is Seneca underline student teacher underline H, and do the same process and put everything in Seneca namespace. So all the modules you create is going to be that, and you're going to need that, I think, starting from workshop 1 that is due next week. Okay, so this week you are submitting your workshop zeros in the lab when you're coming, and we're going to go through problems that if you have with your workshop 0. If you have already submitted your workshop 0 and added me as a collaborator, and submitted me as a collaborator and added me as a collaborator, please take a look at your repository, see if there are any issues with it. When I say issue, it doesn't mean issue in a matter of English. It means issue of matter of GitHub. So when you get to GitHub, in any repository that you get to, that repository over here has something called issues. You see that? So if I see there is any problem with your repository, I will add an issue over here. I'll add a new issue, and I'll mention what the problem is. You're going to fix that and close the issue. This is the process that happens in all application processing that you're going to do in your life. So it is nothing new. If you have any questions, interrupt me and let me know, and I'm going to explain whatever the question is. Okay? So let's put this one over here. Now, so that was the module, and we said for every module we create a unit test to actually test the module, and the unit tests, or any tester, or the main of any thing that you are, the main program that you're using, usually they use the namespaces you create. So the unit test for student, student, whatever that spelling mistake is, the unit for the student module should include student.h and use the namespace and test the module to see if everything's good. Good? You good? All right. That's that. So we are talking about types. So this is what we are going to talk about this week. Types, overloading, references. Okay? And before we begin, while we're here, I'm going to mention to you it's very important, extremely important, to be on time next week for the lecture. We are studying dynamic memory allocation, and if you miss it, you're going to suffer for the entire studies at Seneca College. Dynamic memory allocation is an extremely important thing to know. Very, very critical. Okay. Types, overloading, and references. So, when we talk about types, sorry, I'm just trying to find my start menu. Just a second. I'm going to bring up the notes so it'll be quicker to go through. Actually, it's a good idea to save these things over here. So I'm going to save this in here. Save. Because we might want to use it later on for something, so I'm just going to let them be. And done. Sorry, this is a Seneca computer. Anytime I'm starting Notepad++, it asks me to install it again. Give me a second. My apps. Just a second, please. There we go. Okay. All right. All right. Now back to, all right. Types. Starting with the gentleman over here. Oh, actually, you're first. Okay, so when you go back to IPC144, when we are talking about type, essentially with types of variables, right? If you can help me, what major categories you can divide the variables into? Like, in C language, we have two base categories that all the variables fall into. Do you know what those two are? Can you guess? And you can easily say pass, and the gentleman over here is going to answer.
Strings?
No. Strings are array of characters. Two major categories that all types of variables, double, float, integer, yada, yada, they separate into. Do you know what those two are? Like when you look at all the types that you are using, what is the major difference between the two, you think?
One is consists of just characters.
Please use your opera voice so I can hear you. Okay.
Okay, so like one is consists of mostly characters, so A, B, C making to something, and the other one is consists of just purely number.
Number. So we are saying characters and numbers. That's a perfect response from an IPC point of view. by surprise, there is no such thing in characters in C language. We do not have anything called characters. Pass the microphone back to the lady behind you. We don't have anything called characters in C language. It's a big lie. A character is just a small integer. It's a small integer whose size is big enough to hold the ASCII code of a character. So when you say A, that A is actually number 65. And you tell to the compiler using %C that I want the shape of 65 to be printed. And that's how you get A. So there is no character in C language. So let that aside. So one category is gone and the other one is number. So I want to separate numbers into two categories. They are?
Signed and unsigned?
I never thought it that way. But double values cannot be signed and unsigned. It's only integer values that can be signed and unsigned. You don't have an unsigned double. You have unsigned integer. So again, pass it to the gentleman over there. What do you think? So let's go. So thinking about variables that you create, there are two major, and I want everybody to think. The reason I'm not giving you the answer, because I want you to really think about it. What are the two major types that everything falls into?
The two major types?
Pardon me?
Two different types of variables, is that what you're asking me?
Yeah, type of variables. Type of
integers and characters?
No, he just mentioned that, integers
yeah.
and characters. But we don't have a character. Character is an integer.
So yeah.
The smallest integer is a character.
Yeah.
Okay? Anybody?
Bits?
No, that's compound types and regular types. It has nothing to do with that. I'm talking about fundamental. Thank you. I have to clarify. I have to clarify. Only and only fundamental types. I'm not talking about structures and things like that. In fundamental types, what are the two major types? Anyone? Pardon me? That has nothing to do with C. At C++. I haven't even talked about references yet. In terms of IPC. Pointer is essentially an integer. A pointer is an address, right? An address is a number, right? And that number is an integer. So that's no different with integers. So it's not a different category. Anyone? Should I put you out of your misery? Pardon me? What is the main category of all types in C language, all fundamental types? The main category of two is integrals and real numbers. Integrals and floating point. Integers and doubles. All the types that you have fall in two categories. They are either integers, they don't have partial, or they are double values, floating, we call it floating point. So the correct name for it is that in mathematical name, we have integrals and we have real numbers. Integrals are the numbers that they don't have partials, 1, 2, 3, 5, -3, -2, okay? Real numbers are the ones that have partials, floating point variables we call it. Floating point variables have different types, okay? So these are the two real types that are different in, like literally, the computer looks at them differently, okay? Be aware of it. So when you are saying a pointer, pointer is nothing but an integer. When you say character, character is nothing but an integer. All the other ones are kind of spread around. Now, my friend over there is going to help me with some types of integrals. Give me some samples.
3 point.
No. The type. So get the type name. Like if you want to create a variable, integral variable, give me one.
Float?
I just said integral. You said float. Float is real.
Oh. I got it. Just int.
Int, thank you. Int A. Thank you very much. Pass the thing. Pass the microphone. Next one.
Long int.
Long, perfect. So long int is long. It doesn't make any difference. The same thing. Okay. Our beloved guest. Give me an integer. Other than int and long. You don't know? Oh, by the way, the rule is that when you don't know the answer, you say pass. And don't sit at the edges because you have to stand up and move the microphone to the next person. So if you don't want to stand up and walk, sit closer to each other, because you have to get up and take the microphone to the other person. All right? So can you give me another example of an integer, my friend?
Size underscore t int. Unsigned
Oh, you smarty pants. No. That's C++. We don't have that in
no,
C.
Then
Pardon me?
Are we doing C++?
No, we are doing C now. In 5 minutes, we're going to do C++. But for now, it's C. For 5 minutes that we are here, we are C. We're going to move to C++. Go ahead.
just unsigned int then.
Another smart answer. Okay, unsigned int, correct. That's a thing. But unsigned is something that you can put for anything. Okay? So let me, well, you can now stand up and bring the microphone, or you can move your stuff closer so you don't have to keep moving, and give it to the gentleman over there. Yeah, perfect, thank you. All right, so these are the types. The smallest integer is a character. And after that, we have short. Then we have int, then we have long.
We have long.
Thank you. We have long, LL, and then we have long. No, I'm joking. That's it. That's the 2 is done. Okay? So long, okay? So that's that. That's always. So these are all the integers that you have, from small to big. Now, the size of these things, when I say a character is 1 byte, it's 1 byte everywhere. That's it. There's no other thing. But when I say an integer, you really don't know. It depends on the platform. Anybody knows what when I say platform, what does it mean? Did I ask this question? What is a platform? What is a platform when I say platform? Can you guess?
I think a place where it holds the stories of a character.
Oh, no. I'm talking about platform with respect to programming. When I say is C++ is written in this platform, what does it mean?
Compiler.
Compiler. Not only compiler, but cool. Never heard that word before.
The software that is used to compile the.
So compiler is ran where?
So Visual Studio for this.
So yeah. So compiler is one, and the other one is? No, that's a different story. And the operating system. Okay, you can have an operating system that is 32-bit and a compiler that is 64-bit, right? And a compiler that is 64-bit won't work on a 32-bit. You have to go to 32, okay? So the combination of compiler and operating system together creates a platform, okay? So that's what I said. When platform changes, like right now, do you see at the top of it there's a 64? That means my long is 8 bytes. If I make that 86, which becomes a 32-bit processor, then my long becomes 4 bits. 4 bytes, which is 32 bits. Okay? So these sometimes change. You're going to learn in OOP244 how to actually find out what is the real size of it. Pass it, please. When you finish speaking, just pass it to the next person. And my friend over there is going to give me, so these are all integrals. And now we're going to talk about some real types, which we call it floating point. Give me one.
Float.
Float. Perfect. Pass it. Double? Perfect. Passes. Pass it. And? Pass. There is one that is bigger than double.
Not double.
Double.
Can I
You have to do double, medium, double, long. Okay, you pass, my lady? Pass? Okay, that's enough. You hold it. We had enough passes. Hold it. It's long double. Yeah, close to double, it's long. So, why they call that double? It's not double the size, it's double the precision, okay? Floating point variables use actually 2 integers that are kind of stick together to find out what the value, to keep the value. One is the number that is essentially what is the number, and the other one is the exponent. So essentially, one tells you what the number is, and the other one, so that the number that you have is a floating point number that with one digit, so 1.2, 0 point something, like that. And the other one is the exponent that what number is going to be multiplied to. So you have 1.32 multiplied by 10 to the power of 5. So that 5 is the exponent that they keep, okay? And they keep these two together, and they keep the number. Because of this, floating point can have, I think, around, I don't remember, I don't know, 16 zeros? I don't remember how many zeros. 30 zeros, something like that. So that's as big as it can. The double can go up to 100 and something zeros, so 100 and something zeros, that big, or 0.100 things smaller. And double goes up to 300, okay? Now, with all this size comes imprecision, something that is not precise anymore, okay? Because of this fact, these numbers are not precise. They are not kept in a way that, so essentially if you use floating point for your accounting program, you're gonna start losing pennies and cents in your program, because the additions are not gonna come up correctly. In other words, you are never to compare two floating point numbers for equality. It's not guaranteed. So you can have a logic that ends to the number of 2 in a double number, and another logic that comes exactly to the value of 2. And if you compare the two numbers for equality, it may go false, because one is 1.999999999, the other one is 2.000000001. And from computers' point of view, these two are not equal. You've got to be careful. Yes?
So that's why we should lower the precision to according to our.
You don't lower the precision. Whatever precision you have to check it that way. So how do we check for equality? We reduce one value by another. So if I want to check to see if A and B are equal, I have to do A minus B, then get that value. Then what is my precision? 0.001, let's say. That's my precision. I have to see if A minus B is between 0.001 and minus 0.001. If that value is between the two, it means the value are equal for our business logic. So you have to see what the precision of your application is, and that's the only way to check to see if two double values are equal. Okay? It's a good idea actually to write a function for it. Write a function called equal that receives two double values and does that and returns a true or false. Yes?
The drawback is we lose precision when we compare or add.
Yeah, we lose precision like crazy.
Computers can make mistakes.
Oh yeah. It's not mistake. It's an outcome of the design. It's not a mistake. It's like that by design. To be able to know how many centimeters are here from here to sun, you don't have to be precise. You know what I mean? It's not that important. So precision is different. So double value, if you want that, you have to use long. That's precise. Okay? So, but if what you are doing is an estimate, but some estimates are very precise. You can go to a billionth of a millimeter. You can do that with a double value, if that's your precision. But again, that's the precision. If you go a little further than that, it's not going to be good enough, okay? Keep that in mind. So these are the types. Didn't I just add those 4 things over here? Maybe I didn't. Anyways, so the 0, I'm going to change this to 0, 1. I don't want to save there. No. So 0, 1. So 0, 2 types. That's better. So those were types. Oh, what did I do? I didn't save my previous thing. just say compile and running it to make sure it's there, and then we continue. Okay. We know all about these types. There is an interesting type in C language, in C++ language. Now we are out of C. Now we are doing C++. It's auto, A-U-T-O, auto. What auto is, it checks, first of all, auto can only be done during initialization, okay, not during setting. Do you know what's the, okay, she's taking a note, I'm not going to bother her. Do you know, take your note, do you know what is the difference between initialization and setting by any chance?
Initialization is once like when we are declaring the variable.
And setting it at the same time. So initialization is when you create a variable and you put a value in it at the same time.
Yeah.
Integer I is equal to 5.
Yeah.
That's initialization. Setting is I is equal to 5. There are two different beasts. Be careful. And this is something extremely important in C++ that you're going to face later on. Integer I is equal to 5, and integer j is equal to 5. There is absolutely the complete difference between the two. Completely different. They are two different things. Why? Because when I is getting created, I starts its life with 5 in it. It doesn't have any value prior to that. But for j, first it has to exist and then set to 5, which means it's going to have garbage in it, and then the garbage is overwritten by 5. Two completely different things. Extremely important. Okay? Understand this? That brings us to auto. Auto only works for initialization. So I can say auto, D is set to, that means D will be a double. I can say auto, that means 5 will be a long, because I put the L after. But if I say auto, now k is an integer. If I say auto, now L is a long. Okay? Please go investigate and find out what are those postfixes that I put after each to change the literal's meaning. If you don't mention the number, by default it's double. If you don't mention the number, by default it's integer. But find out what the postfix are for different types, because in future you're going to answer those questions in the test. And I'm not teaching it; you have to find it out yourself. Research, okay? So find out what all the postfix for literal types are. We didn't talk about unsigned. Somebody mentioned unsigned. When you mention unsigned, anything can be unsigned. Okay? Anything can be unsigned. Now, to mention what is unsigned, I'm going to do this. Will it work? Oh yeah, here I am. Okay. How many fingers? 10. Are we right? 10? Are we okay? This is 10 fingers. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, correct? So from 0, I have 10 fingers. It goes from 0 to 9, right? Now let's say I want to show negative values with this too. I have to decide if this is 0 or this is 0. I'm going to say this is 0. If this is 0, I'm going to have -5, -4, -3, -2, -1, 0, 1, 2, 3, 4. Because of this, when you have an unsigned value, you go to the maximum number that an integer can take. But when you go to signed value, which is regular integer, negative values are always one more than positive values. Remember that. So a character, if it's unsigned, it's 0 to 255 because it's 8 bits. But a regular character, as a signed integer, is from -128 up to 127. Be aware of that. You good? All right. Yeah, so that's auto. Now, so this is initialized, set to 5. So this is 0, 3. Auto. Let's say I want to create a bar chart. You know what the bar chart is? Shows that you have lines and chart shows the amount of stuff, right? So for that, I need to write a function that draws a bar. So I can use it for different size and values. You good? Let's do that. So I'm going to create a function over here. I'm going to call it bar. So if I want to draw a bar, it's essentially number of characters I'm going to print on a line, right? What do I need to pass to this function to draw a bar? If you want to write a function that draws a bar, what are the information that you need to pass to it, you think?
Maybe
Just by design. Anything.
statistic.
You're so quiet. I bet you cannot hear yourself. Louder, please.
I think statistic, like numbers.
A
like
number. So I
percent.
need to see how much you can pass it to the gentleman. Actually, no, thank you. Please sit closer to each other. It's friendly. It's good, and I don't have to. Okay, so a number. So int the length of the bar, right? What else do you think is good? When I'm drawing a bar, I'm going to print a character few times. So I have the number that is len. What else do I need for this?
You need HR?
HR.
No, HR.
Oh, a character. Slow. You were very fast. You said a char, and I heard HR. Okay, that was cool. Okay, so yeah, we need a character. So what to fill it with, right? So I'm going to write over here character fill. What to fill this thing with, and that becomes so. So in here, I'm going to call it length. So that becomes the declaration of my function, and my definition obviously is going to come down here. And I don't need these things anymore. So in here, I'm lazy. I'm just going to put over here L. Enough. Remember, always have this habit. The prototype or the declaration of functions must have argument names that are big and descriptive. Okay? When I write over here bar, length, and fill, everybody understands what I'm doing. They know that's the length of the bar, and that's what I'm going to fill it with. Okay? I see many, even of my colleagues, they do this. Because it works. But it's absolute nonsense because from the prototype, you don't know what the heck is that. Okay? You have the opportunity to write something that later on is going to describe to you how your function works. So be as descriptive as you can in your argument names in the prototype. If you want to, after, put something small to work with it quickly, that's fine. Okay? And this is something that I did not mention in the other class, but it's a good idea to have this practice. Do slash 3 times. 1, 2, and poof. Okay? What happens, it gives you this. So in summary over here, you draws a bar. A bar for a future bar chart. Okay? Length of the bar. Of the bar in characters. Oh, that's enough. Length of the bar. Fill is character to print the bar with. Okay? So what happens is that later when you bring your mouse over here, this happens. See? It tells you exactly what you have. And it's in most new IDEs that happens. It helps you a lot. Okay? So I know people don't like to write comments. Okay? If you have Visual Studio 2026, it actually writes it for you. It actually looks at the function and guesses what the function is. It's pretty cool, actually. Sometimes it makes mistakes, but it's good you fill in the blank and you do. Anyway, so that's that. So keep it like that. I just wrote that one. I'm not going to write anything more, but the rest of it. So in bar over here, I'm going to write 4 integer I set to 0, I less than L and I plus plus. And I'm going to say over here, C out F and C out new line, right? And then in here, I'm going to say bar 20 with a dash. Three years later, this is what we have. Are we okay? We good? Questions? We good? Let's actually do it with an asterisk. Okay? Now, say most of the time I want my bar to be drawn with a dash. So what do? I'm going to say, if that's the case, then I'm going to write over here void bar with dashes. And I'm going to put only length over here. Right? And this is going to be the function. All right? What do I do in here? I'm going to say bar. Why did I type my name? That was interesting. Bar. It's muscle memory. Bar. Bar. And in here, I'm going to say length and dashes, right? Huh? My name? No, I never use my name in password. Okay, so, oh, I didn't call it. So in here, I'm going to say bar with dashes. Bar with dashes, and I'm going to put over here 40. Okay, this is the point I want to make. So when you say, when you go to a bank, they say, please, I want to have your signature over here. What does that mean? Like they give you a document, they say, I want to have your signature here. What does that mean?
That means to sign in that area?
Yeah, you just sign that area. You sign it. What? A signature. So what does that signature indicates? It's something unique that you can write and you can be identified with easily. There are people, experts, that can check the signature and see if you have drawn it, right? So signature identifies you, okay? Now, in C language, what is the signature of a function? C language, not C++. What identifies a function and makes it unique? It's name. The name of the function identifies the thing, right? So that's why you cannot have two functions with the same name. Correct? In C++, a function signature is its name and the types of its arguments. So bar over here is actually bar int char. That's the name of the bar. Because of that, I do not need to name this bar with dashes anymore. I can simply call it bar again. Why? Because this one is bar int. Therefore, no confusion between the two. You can have the same name, different arguments. You're just fine. This is called overloading. This is called overloading. And I can even say, okay, let's say if I just want to draw a bar like that, I want the bar to be 79 characters, a long line to be written. So I'm just going to write over here void. Sorry. So as you see now, if I now draw a bar, just like that, that's what's going to happen. Not only that, I can say, okay, this bar that you're doing, you want to do it with different characters, not the same length. You can actually create void bar char fill, which is essentially, you see what I'm doing? I'm putting over, go to the screwdriver, and I say, do like that, screwdriver, create definition, and poof, it creates it for me so I don't have to type it. It's for lazy programmers. Okay, so now I'm going to say over here, bar 79 and fill. So now I can actually do this. What do I do? Like that. We good? All right? We understand what happened? This is called overloading. Overloading is, overloading is a feature that we kind of had before in C language, but you never noticed. You write A is equal to B plus C, right? And that plus can receive anything. We can have a double and a double, integer and an integer, integer and a double, right? You had it before in C, but only for operators, not for functions. Now we have it for functions too. Okay? Are we good? So this is called function overloading. So essentially what the compiler sees over here is bar int char. This one's going to be bar int. This this one's going to be bar, and this one's going to be bar char. And therefore, there are 4 different functions. Are we good? Function overloading. Now, when you look at this when you look at this special scenario, this bar is all the bars are essentially a call to this bar, correct? Right? Wait a minute. Wouldn't it be nice if I could say, hey, if they did not provide this one, use a dash. Then I didn't need to write this function, correct? You can do that. I can literally say, which means if they give me the fill, I'll use it. If not, I'm going to use dash instead. Therefore, this is not needed anymore. So when I'm saying bar 40, it is actually calling this one. But f by default will be a dash. Got it? Right? And this one too. I said when I don't want to put anything, I want it to be 79, right? I can do that. So I don't need this one either. But can I put a default argument for this? No, because there's no way that I can make it in a way that it can, you know what I mean? How can you? It does, because character comes second, right? It won't work. I can't do it. For that, I have to overload. So when you can use default value for arguments instead of overloading. It is the exact same thing, no difference. And it's actually much more efficient. Because in the other one, you are calling a function that is calling another function. That's 2 jumps for CPU. In here, you're only calling the same function, passing different values. If the values are not provided, it uses a default value. We good? This is called default argument values. And it works, as you see, exactly the same way as if I didn't change anything. It works identical to the other one, but less coding. Okay? All right. You're going to see in future many times you're going to need to create functions, and I'm going to ask you to, I'm not going to tell you to put default value. I'm going to ask you to create these 3 functions. If you're smart enough, you'll look at it and you say, oh, it's the exact same thing. I'm just going to put a default value instead of writing another one. Saves you lots of time. So in tests, I'm not going to ask you to put default value. I'm going to tell you, I want a function with this number of arguments. I want a function with this number of arguments. And you see one is less than the other one, and it's just the default value for that. Then you don't write the second one. You simply put a default value. Be aware of it, okay? So when I came to Canada, a long time ago in a galaxy far, far away, I went and worked in this recycling factory. And the very first thing they did, they changed my name. Because the manager of the factory says, your name is Fardad? I said, yeah. Oh, that's hard. Can I call you Freddy? So I became Freddy. So for 1.5 years before I came to college, I was Freddy. Quite an honor to be the same name as Freddie Mercury, but yeah, not the good voices like that. But anyways, I was Freddie, all right? So when they changed my name, did we have 2 Fardads? Or we had 1? We had 1, right? So what they did, they just added what to my name, what they call it? They added an alias, right? So you can add an alias to sign. Many people do when they come over here. Many, many people do, and that's very fine, okay? Because you want to be able to blend, and be easy to recognize. Like my name, seriously, like when I speak in English, I say, when they say, what's your name? I say Fardat, which is absolutely wrong. That's not how you pronounce my name. My name is Fardot. But if I switch to that, I feel like my tongue is not working properly. It's difficult to switch accents, eh? So that's the thing. It becomes easy, but last name I couldn't change, so you have to suffer for it. In my examples, when I write something to print, I always write Fred Soleil, so that's the abbreviation of my name, Fardat Soleimander. So that's the thing. Anyways, so we can give someone an alias and then look at, call the person, access the person. So if you know my name was Freddie and he says Freddie was teaching C++, it was Fardat, right? And I says, oh, Fardat wasn't beep today. It was Freddie that was beep today, right? Same thing. It doesn't make any difference. Are we good with this? Do we understand that? We can do that in C++, okay? We can actually give variables several names. There's absolutely no problem with that, okay? So you have integer value. I don't know, I'm going to put over here 10. Okay. Now I can put a new name for it. So I'm going to call that one V. Okay. So in here I can say integer reference V is equal to val. What does it mean? It means I have only one integer, people, not two. But it has two names, V and val. They're exactly the same thing. When I print V, 10 will be printed. And then if I set V to 20 and I print val, 20 will be printed. We understand? We good with this? Right? So this we call a reference, okay? References don't create new things. They just become new names of already existing things. Now be careful what I just told you in a very short statement. I said they become the name of already existing things. Remember that? Which means you cannot have a reference without an already existing thing. I cannot just say double reference A. I can't do that. It must be reference of something. Okay, you cannot just create a reference. We good down to this point? So I'm going to call this now let's go back to here. How C language, not C++, actually both, how both languages call a function. When you call a function, what happens behind the scene? First of all, let's analyze what a function is. Look at line 22. What is line 22? Line 22 says, I have a function called bar that accepts two arguments. The first one is the length and the second one is the filling, right? So that int L is essentially a variable that is created in bar and dies after the bar is gone, correct? Where does L get its value? Actually, where does L, you're up for it? That was easy. Where does L get its value? It's a very easy, usually easy questions are the hardest to answer. You know what I mean? Like, what do you, like, yeah, anyway. Where does L get its value?
I'm not entirely sure, but it's getting a value from somewhere within the memory.
No, 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 no. How L gets its value?
Oh. From
A
a
function,
in main or
from a
main,
function call
main.
in main or anywhere you call it. So arguments get their values from where they are called, correct? So when you are calling the function over here, a function call is actually translated to this. Take a look. Please pay attention. Bar int L equals 20, character F set to asterisk. That's how the function is called. What that thing is called? Initialization. So when you are calling a function, the arguments of the functions are initialized by what you pass them. Do we understand that? Does that make sense? Does that make sense? So I could change this over here like this. I can write over here character star is set to asterisk, okay, right? And put over here star. If I do that, then what does it change to? This becomes star. That's literally what happens. I'm not dancing around the thing. It's the exact same thing that is happening. Okay? And that F gets created, getting initialized with star, which means it takes its value and uses it yada, 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 and it dies. And that's why the values don't change when you change. The original values don't change when you are in a function because they are copies of things. Are we okay with this? Okay. So I'm going to call this how a function is called. How a function is called. Back to our, didn't I just save it? Sure, save it. Anyways. Lady, what is the output of this program? Take your time.
30?
Don't be tricked by what I know.
Wait. Wait, just one.
This is how what a walkthrough is, by the way.
Yes.
Don't.
So we're replacing val and
So,
arctic.
so this is what happens. So let me write this. So this is going to be add 10
And then I
integer
equals-
val set to I.
Exactly. So I is 20, and now it's entering the function at 10. So
Val becomes,
val becomes 30,
yes,
but there is no return.
therefore it dies, correct?
Yeah.
Analyze it, perfect. Therefore in add 10 val dies,
Right.
30 dies, comes back,
So it comes back at 20.
thank you, I remains 20, correct? Are we okay? Now you're my victim. I'm just going to add one character to this, actually two. One for the comment, one the thing. So I'm just going to do this. Take a look, 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 take a look. Oh, not there, not there. Now analyze it. Go step by step. So I becomes 20. Keep
Yeah.
going.
Yeah, I becomes 20. Then you do the add 10. and
Add
that's
10 is called. So integer reference val.
Yeah.
I. What does it mean? It means val becomes a new name for what? I.
Yeah.
So now in add 10, val is added to 10.
Yeah.
But val is a new name for what?
I. Or
Therefore, what's going to get printed?
I.
Which is?
20.
Ah! I just added 10 to it.
Oh, 30.
30. Okay, got it? So you see what happened? That's a beautiful side effect of references. So as soon as you do this, you don't need pointers anymore. If you wanted to do this in C language, you had to do this: void add 10 integer pointer val ptr, and then in here you had to say target of val ptr plus equal 10, right? And then to actually do that, you had to write add 10 address of I, and therefore add 10 will get integer pointer val ptr set to address of I, and therefore when I did C out I, what would happen? Val ptr becomes address of I, target of val ptr is added by 10, and therefore I becomes 40. Right? But in C++, you don't need to do that anymore if you don't really need the address. You just pass a reference to it. So it's going to take its name and do whatever it's supposed to do. References are your friends. Okay? Are we good now to this point? All right? Now get ready for the next one. So we run this, and 3 years later, we'll see that it's going to actually. So I'm showing both of them, so you'll see it becomes 30 and 40. Okay? Those are references. Let's have a C out over here to just for the fun of it. So we have all three, 20, 30, and 40, so we know. Pass it to the friend. Okay. Be ready for this. This is a very tricksy one that is going to be in your midterm. Okay? So I want you to tell me what is it going to be. Got it? Okay. So this one was 08 reference intro. Oh, not reference intro, references. Pass by reference. So from the call, you can't really say if it's passed by reference or value. If you look at line number 13, it is absolutely impossible to tell if the value of I is going to change unless you go check the function, see if it's received by reference or not. Be aware of that. All right? Ready? Analyze it for me. See, using these knowledge, a reference is a new name for an already existing thing. Okay? So let's go through it. Line number 11 prints the I that is 20, correct? Line number 12 passes I to val. So val becomes a new name for I. Therefore, val inside add 10 is I, correct?
Correct.
Which you're adding 10 to it. So it becomes
20.
20. Fantastic. Now, that is returning val by reference. Now, add 10 is a new name for val, which is a new name for?
I.
So when I add the function by 100, what is being added by 100?
I.
Thank you. So the outcome is 110. Got it? Anything can be a reference, even a function. So that function, the entire function, becomes a new name for the reference it's returning. Got it? You're not supposed to get it. That's why I call it crazy reference. Okay? But please go home and write few things. So let me just make it easier for you. So first of all, I'm going to write this. Let me execute it first. Make sure it works. 3 years later. Actually, 130, not 110. 130. Sorry, because that makes it. Yep. Sorry for the lack of math skills. Okay. This crazy reference comes extremely handy later on. Okay? This is explanation for it. That's essentially what it means, right? Because it's receiving a reference called val, and it's returning the same thing. Therefore, the function itself becomes reference of I. Therefore, unlike other things, the function can become a left value. A function was never a left value before. You always had it at right side, right value, to assign it to something, to extract it to things. But this one, you can actually. I can actually do this. I mean, like, I can simply do this. I can say, see out 10, or I don't know, 20 plus reference of, wow, reference wrapper. That's 345. Reference of I can do that. You can return a reference and don't do anything and just extract the thing. It doesn't matter. So in here, essentially 20 plus reference of I, whatever I returns, which in this case is 120, it's going to become 140, right? So the good thing about references is that they can stay at left or right side of the assignment. It doesn't make any difference. Got it? And that's going to make humongous amount of difference in future, okay? When we learn how to create our own custom arrays. You're going to see it soon, okay? Are we good down to this point? So this is crazy. If I run this, so this is, oh shoot, I changed the wrong file. Sorry, copy. This was the one, right? Right? Yeah. That's crazy reference. This is crazy reference explained, okay? Okay. That brings us to the last thing before we go. Now, the question is, the class ends at 12:30, right? You want me to go over this? It's around 15, 20 minutes lecture. It's not lecture, actually. I'm teaching you IPC 144 again, okay? Pointers. You all suck at it. I have to go through it one more time to get ready for the next step. Okay, so I want to go through pointers. So we can do it, and then if we finish early, go home, or we can take a break, come back, do it, and if it doesn't finish, it leaks to the next day. Which one do you prefer? Do it now? Everybody's okay? Okay. For that, you're going to get 3 minutes break because I have to set the stage for it. Okay? And for that, I have to hide the screen. means blank screen. Okay. Three minutes, okay, 3 minutes. You're like you just walk to the table and come back. It's not going to be it's not going to be very long. Okay. Oh, now I have to edit it. Damn it. Because I didn't stop the recording, therefore all the staging that I did. Anyways, doesn't matter. I won't edit it, doesn't matter. All right. So let's talk. Seriously, 3 minutes? We're going to wait 2 more minutes and I'm going to start. Yeah, they're here. They're gone. 3 of them. Casualties. I shouldn't have said. Let me see where they go. They're coming. I said 3 minutes. Come on. Hurry up. So, pretend that we are the designers of the C language and we want to design something. What do we want to design? We want to design some kind of a variable that is capable of holding the address or location of other variables. First of all, we have to understand what is memory. Memory is essentially an array of characters that starts from 0 and goes up to the money in your pocket, how much RAM you put on your computer, okay? So that's essentially what is a humongous array of characters. And because like the address was too big, I just wrote the 3 right digits. So an address is nothing but an unsigned integer. It's just a positive number, right? It's an integer, it's a positive number. That's all it is. So essentially, when you are programming and you create a variable in your program, you request for an integer and compiler negotiates with the operating system and it borrows a piece of memory and tags it with your name, with the name you put, so you can actually use it. And then if you create a double one, it finds some other empty space that has 8 bytes and it creates a double for you. We're good with that? Okay? Obviously, if you put a value in that variable, it sets the entire thing to the variable that you had. So essentially overwrites the whole 4 bytes for that. My question is, what is the address of var now? Who has the microphone? Oh, it's a virtual person. Thank you. So Ah, they're gone. All right, so, oh, that's, okay, sure. I'll bring it for you. So what is the address of var? Which byte number it starts in?
For which one?
108, correct?
Yeah, for
It-
var.
It starts at 108. So the address of var is 108. Not 109, not 110, not 111, because those are all part of it, right? So where it begins, that's what its address, right? And what is the address of dvar?
Starts at 132.
132. So 132 is the address, correct? All right. So, and if I set it to something, it writes the entire thing with the value that you have. We good down to this point? You're okay. All right. So now what I want to create a new type of variable. A new type of variable to hold other variables' address. I'm going to call it a pointer. So we call this variable a pointer. Therefore, pointer PTR, because it doesn't matter how big or small your object is in the memory, the addresses are all the same. So the address of a double, address of an integer, address of an employee, address of a car, address of a transcript, they are all 4 bytes. This is a 32-bit system, let's assume. So it doesn't matter. We good down to this point? Okay. So I'm going to create it like this. And I can, that pointer is essentially an integer, right? I can set any value to it. So I can say over there, for example, 102. When I put 102, what I mean is that that is supposed to point to address 102, correct? But nothing is sitting at the 102. It's a stupid thing to do. It's like writing an address of an envelope of an address that doesn't exist. It doesn't make any difference. It gets returned, right? And that's the thing. So it's better to put an address over that actually makes sense, which is 108. Here we go. Are we okay with this? The problem is that you don't know what the address of the things are. So you have to ask the operating system, ask the C language to tell you what the address of something is. Therefore, that pointer should be able to, we need to have some kind of a thing to extract the address, and we call that address of. So PTR is equal to address of var, which is fine. When I do that, then it becomes 108. Okay? And obviously, if I want to put something to var, I'm going to put assignment in front of it. Sorry. If I want to put something in a pointer, I put assignment. It means the pointer is being set to something. But if I want to go through the pointer and point and write what it's pointing to, I have to tell to the compiler that don't set the value of PTR, but set the target of PTR to something. And that essentially will cause the target to be set to something. Are we okay with this? So that's essentially what pointers are. Now, and obviously if I print the var, the var will be printed. If I print the target of, again, that will be printed. But if I print the PTR itself, then the address will be printed, where actually that thing is in memory. Are we good with this? All right. So let's try it with the double. What if I put the address of dvar in PTR? If I do that, 132 is supposed to go in it, right? And if I want to set the target of PTR to that thing, then how the compiler is supposed to know that it's 8 bytes now, not 4? The PTR before was pointing to an integer, and we just hoped that it's going to write an integer in there. But when I'm doing it like this, how does it know that it's supposed to overwrite 8 bytes? PTR is not telling anything to the compiler of what the target is. When the compiler is executing target of PTR, it's only executing that. It doesn't know what is sitting at the target. So it doesn't know what to overwrite. Because of that fact, this is not a good design. I need to tell to the compiler what this pointer is pointing to. Because of that fact, I have to make sure that I say integer pointer PTR, not pointer PTR. When I say integer pointer PTR, the address of var goes in there. Now the compiler can give me an error if var is not an integer. Now compiler knows PTR is an integer pointer, and if var is a dvar, it's going to say, hey, what the heck you're doing? This is an integer address. You're putting a double address in here? That's not going to cause trouble. So first of all, that's detectable. Secondly, when I say target of PTR is 234, it knows PTR is an integer and therefore overwrites it, and everything works. And because of that fact, if I want to actually have a double, I cannot use the same pointer. I have to create another pointer, say dptr, that its job is to point only. The size is the same. They're both 4 bytes, as you see. But the only difference is that one is supposed to point to a double, and the other one is supposed to point to a thing, and it keeps going like that. And everything works. We good? Are we okay? So what I was saying is that I should be able to say integer pointer p. Then I can say p is equal to address of, I need an integer, val, correct? Then I should be able to say cout target of val. And I should be able to say, oh, not target of val, target of p. P. And I should be able to say target of p set to 30 this time, and then do cout target of p, right? And when I run this program, obviously, hopefully, if what we designed is correct, it's going to actually work, and I'm going to have, as you see, with target of p30, 23 and 30 printed. Are we okay with this? We good? Now, how does this? Nobody ever told you about pointer and address of, right? You just use asterisk and stuff like that. Okay. Let's see how does it work actually. So pointer in C is presented with asterisk, right? So essentially, in here, I shouldn't say integer pointer. I should say integer pointer, correct? And double pointer, correct? And those asterisks don't belong to PTR and dptr. They belong to int. So int and star together mean integer pointer. Never call that integer asterisk or integer star. It is integer pointer, and it belongs, even if somebody sticks it to PTR. If you've seen people do that, right? They write int star PTR. Wrong. It should be the other way, right? And address of is ampersand. So essentially, when you are writing address of, you have to write ampersand something, and it belongs to that. So dptr is address of dval. When you see the ampersand before the name of the variable, first of all, it indicates that the variable is a pointer. Second of all, it means, first of all, it indicates that I want to extract an address, and what sits at left side is a pointer that suits that. Because it's a double pointer, address of dvar can go in there. And sadly, they chose asterisk for target of 2. So you say over there, target of dptr with an asterisk beside the pointer name, and over there. And that's actually looks like. Now, target and pointer are both presented with asterisk, and it's very confusing. How do we understand that? If asterisk comes after a type, it means type pointer, whatever it is. If, like integer pointer, like double pointer, like struct employee pointer, which in C++ we don't have the struct anymore. This was a C lecture, okay? If asterisk comes in front of a variable, it is a unary operator, like -5, not a. And it essentially means target of. A is target of P. You don't need to know that P is a pointer. Looking at that, you know P is a pointer. If I say target of T is X, you know T is a pointer. And never say asterisk T. I forbid it. Don't do that in my class. Always say it what it means, then it fits. Okay? If I say A is equal to B multiplied by address, target of C. The other asterisk. So whenever you look at an asterisk and you go, ah, that means multiplication. When you go, ah, that either means target of or pointer, right? Okay. And this means E is equal to target of M multiplied by C multiplied by C. We good? All right. So the question is, how the heck this thing worked? It was because of this. I just wrote 3 define statements, and I say anywhere you see target of, replace it with an asterisk. Anywhere you see address of, replace it with an ampersand. Anywhere you see pointer, replace it with an ampersand. So these are preprocessor directives. Anything you start with hashtag tells the compiler to do something before compilation, right? So I just told the compiler, any place you see target of, remove it and put an asterisk. That's why my code is working. Because it essentially becomes integer asterisk P, which is integer pointer P. Okay? So do that, and you're okay with pointers. That's the gist of pointers. And please, please do not give pointers extra credit. They are just variables. They don't do magic. They are just variables. Their job is to hold other things' address. And then you can use them to access them. Done. So in C language, they say this is passed by value, this is passed by address. You've heard that, right? There is no such thing. Everything is passed by value. That value sometimes happens to be an address. When you have a function, like, oh, this wasn't the one. When you have a function like this, val ptr is just a variable. Its type is an integer pointer. And the address is passed by value. There is nothing over here passed by address. Yes, I is passed by address. But that's because of the syntax. It's because of the logic, not syntax. Everything is passed by value. Everything in C is passed by value. C++ adds one feature. You can pass by reference to. That's all. So when what you're receiving in a function is an address, you can use its target to do remote things. If in here somebody does this, you are changing the address inside val ptr. It has nothing to do with I. It's a variable. It's like in that thing I had 108, I add 1 to it. Okay? Remember, pointers are just variables. Their job is to hold the address of other things. And that's what they do. Follow that logic, and everything falls in place. There is no magic behind it. Okay? And please use the proper names. If asterisk comes after a type, say type pointer. Never say type asterisk. If the asterisk comes before a variable, it's always target of as a unary operator. When ampersand comes before a variable, you're extracting its address. That's all. Be good? That's all. So knowing these, then we're going to go further in. So the next time you're coming in, I'm going to talk about array of pointers, and that, I think, ends everything. And then we're going to do workshop 0 together, make sure you are doing everything right. Please, I beg you, I beg you, I beg you, do workshop 0 following the instructions first, then come to the class. Okay? Don't come over there and say, help me do everything from scratch. I won't do that. I'll send you home and ask you to do it again. Okay? Please do it. Thank you. Have a beautiful one. Thank you, sir.